So today I am going to teach you all about data science. So what is data science? So data science is an interdisciplinary field of scientific methods. So only for statistic method. So using scientific and process algorithms and the mathematics all are combining in one field to find the features or find the relationship between different variables. So if you want to find the feature, if you want to find the relationship among the variables, we need particular technology. So data science combines all the things. So statistics, mathematics, and physiology. So using structured data, unstructured data. So using structured data, we can find the classification, but we can easily classify the data. So unstructured data, if you have any unstructured data, we must find the pattern among the unstructured data, and then we need to find the relationship, or we need to find the prediction based on unstructured data. So if you have unstructured data, we first okay. Okay, first we in data science we need to find the we need to analyze data. If you have any data, we need to what is the relation between two variables? What is the relationship between two or more variables? We need to find the relationship. And what is the relation means, and then how relations is positive or negative, and then we need to plot that. We cannot visibly view, we cannot visibly visible all data. So because if you two or three data we can visible, so but millions or like that data we cannot visible. So that times we need to summarize like mean, median, mode. Using that summarizing methods, we can summarize one values. We can take decision based on that values.
No, few people might be in English. English, right? Everyone. No. Few other language people are there.
We have called. We are in correct with GoToMeeting of somebody who can do English. That's it.
Lots of people are there.
Oh, okay.
Okay.
So in data science, we go to the statistical method. Why we need statistical methods? Statistical methods help to find a relationship. So here first we step exploratory data analysis. Exploratory data analysis is nothing but so just plotting the attributes and find the summarizing using mean, median, mode values. That is only. Just we can here. Now I am going to teach about statistics using Python. Okay, here we need to visualize the data. We need libraries. Here I import libraries. Matplot. Matplot is help to visualize all data, and then Cpon like that. So pandas help to combine all data using a data frame. It's combined. NumPy is help to import all mathematical operations. This is a n-dimensional arrays. Like arrays is single dimension. Here is the number is a n-dimensional array. So here I import all libraries. What kind of libraries I want? Here I imported. So here this is the data name. So I have file names in, I have all files in pen drive. I already distributed. Okay, here's the mention here file name. So assign to variable name, so file name. Here I have mentioned column names. So here column list is assigned to names variables. Here I created dataset object is the feed is the panda. Here I have imported panda as PD. So here PD read CSV. This function help to load data and read. If you want load or read data, so here is we can use this function read underscore CSV. Here is the file name. I pass the file column names. Here I want to only view 5 rows data. So here I have used dataset. Dataset means here is the first data here. So dataset dot head. Only I have first. This is the default. If I want 10 rows. So here we can mention 10 rows. Here if you pass any value, you can get that according to rows. And then this is default only 5. So and then here I passed only first view. Here first one, this is my data is working or not. I want to check. That is why I have just here used a head function. So here I want to check all the details. So just I use info function. Here this data is here I passed pandas data frame. So here is the data type is data frame. Okay, here 150 data here in this files. So here is the 150 entries means the 150 observation. Here we can call this rows or observations. Here is that this name is column names. We can call it features. So final value class is we can call target variable. Here is the 150 entries. Here Sebel length, Sebel width, pedal length, pedal length. I would like to sorry for that. This is the iris data set. This is one kind of flower. Okay, this flower with length within the length 3 kind of flowers data is collected here. Three kind of data is collected here, length and width based on here. So here we are going to relationship between using length and width, and one flower to other flower. We are going to find the relationship between one flower to other flower using only this data, length and width, pedal length, the pedal width. If you want to see flower, this flower. Okay, this data here is the Sebel length. Sebel length data type is float 64. Here Sebel width is float 64. Pedal length float 64. Pedal width float 64. And last one variable class this is the object. So here data type, so four columns is float 64. Last one is object. So here is the size, memory size. Now here I separated data vertical color pedal length only. Here the so this data I want to separate. This flower only I want to separate. So here I have first vertical color, pedal length, data set. This is a location. Here is I mentioned that flower starting position. The starting position is the enter. So here is I mentioned column name. Okay, this is like that. This is the pedal width. This is a data set dot location, the starting point of observation. So ending point of observation is the column name. Here is the column name. Here I have mentioned. Now using only one variable, using now I'm going to visualize, means that here's a histogram. If you want find only visualize the one variable using histogram, is a histogram plot you can use. This is a histogram plot. This is a x-axis, so that length of vertical color pedal length. This is a y-axis count. Count means that frequencies, means this is a 3.0 starting point to here is the, we can call this pins. This one pin, two pin, three pin, like this. Between 3.2 here is all value vertical color pedal length is coming this one pin, this pin, and then this is the count of the value is 5 or 6. See, anything is between 3.0 to, so this was coming, so 5 values, here is the 5, but here is the 1. Okay, and this is like that. All data is we visualize 150. This is a 150 observation come here. This is the ranges. This is the frequencies. How many data are here? Say 8. So, but what is the problem in histogram? Here histogram we cannot visualize all data. So because all data is coming in pins, so we cannot visualize all data. Now we go to another plot. Here is we can call this swarm plot. So this swarm plot, here I have is this swarm plot, because here I can't see all data. So I want to see all the data. So I use this swarm plot. Here is the, this is a dummy variable. SNS here I imported from here. import SNS. CPhone is the visualize purpose libraries. So as the SNS here. So SNS and Matplotlib is working together. So that is why the SNS does dot set function I have used, and the histogram. Yes, oh I moved here, right? All are understand this line? I think so. I did not explain all this line. Here is the I would like to explain here. So this is the PLT is the Matplotlib is the PLT, and then the histogram function is used to visualize histogram plot. Here I passed length. So this variable name here I passed. So edge is the black. Black is this edge. So if you did not visualize, if you not pass edge, so like that. So I want to this. Here I passed. I got it. So separate, I want separate, that is why I was black edge color. So this line width, the black line width is I was 1.2. Here I need a x-axis label name. So PLD dot x label name. Here I first label name, and then here I want y-axis name. So here I first count. So always when you plot any variables, you need to use x-axis label name, y-axis label name. So this is BLT dot show method. If you pass only, you can get the visualize. So if you not pass, so SNS dot function here as fast with that is why you can come. But if you not pass PLD dot show method, so you cannot get this result. So now we move here. Yes, this is this method SNS dot swarm plot method here.
We don't need to use PLT brush or in Jupyter Notebook, it will be usable. But if you're using separate ideas like Python 3 or 3.4, in terminal you should put PLT.show, then only it will show. Otherwise you can't see the output.
So
use ideal. You're using now.
Yes, this I
use. So
used.
you should use PLT.show. You don't need to use PLT.show, it will be visible directly. But when you are using Python ideal separate one, there you have to put PLT.show, otherwise you won't get the output.
Yeah, the main reason if you are using the Jupyter Notebook, the interpreter will be functioning directly. That's the reason we don't want show. It's an action. Show is the action. But the other IDE tools will help to try the action problem. That time it will be compiled.
That's so we have to use that.
Yeah, that's the main reason.
Okay, now we move to here. B swarm plot. That is why I can't see all the data. That is why I'm going to use B swarm plot. This SNS here contains the swarm plot methods. That is here I pass class name. This is a class name. Here is the flower name. Here is I used here is a flower name. Here and then y-axis as a petal length. So all flower here is a one flower is a color with Jinica. So 3 color flowers. I visualize the all flowers and then one place. So here is the name. Here this is a file name. Data equal data is the file name. I pass this and then is the x-axis name, y-axis name. So and then I was show method. But but I visualize the all data. This is the very 150 rows data. But if I got 1,000 or if I have million data, so I can't see all data because all data is overlap. Edges are overlap. We cannot take any decisions. So based on that. So now we move to another method. So ECDF. So this is the empirical cumulative distribution functions. This is the alternative method for this stream plot. So here I define the function. If you don't define this function, we can use the Python contains default function, the ECDF, like that. So you can use it here, but this purpose is to visualize how the function is defined in Python. So here also, here is I defined the ECDF data. Data here is the first from here. So here I already assigned the data equal to data set. So here the data I passed. So length of data is the, here is the 150. So now I need to start out, means that here all data here I passed start, and then the y-axis we need to arrange, means that we pass the y-axis values, how many data here, then we need to, means that 20%, 30%, 40%, we need to count like that. So here as I have first formula, here I pass the x-axis, y-axis. So here as the ECDF returns two values, x and y-axis values. Here we pass here we call this function, and then we get result x and y. That value is stored here. So and then I plot these values, x-axis and then y-axis. This is the plot methods, plt dot plot methods. Here marker dot here we get the dot line. So here we don't like any lines. So that is why here we use a line style equal none. We want dot, so that is why marker dot. We don't need line, so here we use none. So plt dot margins 0.02 means that is the outline margins. So I just change. You see that this is outline margins. Margin values I first here is, so here is first this is the x-axis label name, y-axis label name. Label name is a dummy variable. Always is a dummy variable. Here is also method I have used here.
What is ECDF?
Sorry.
ECDF.
ECDF is the empirical cumulative distribution functions. Here the all data is, we can visualize, we can plot all values here. We cannot see the all data is piece form plot. So because data is merged one by overlap, edges are combined. This load here we have load data. This is only 150 data. But if you have 1,000, 2,000, 20,000 like that, if you go above we cannot see. So edges are merged. We cannot take any decisions. But we can take decision. Means that 20% data is above 3.50 size. We can take decisions like this. This is 80% of data. They means that 80% of flowers size is 4.5 petal length. You can take like the decisions. Here is the UV 0.6. 0.6 percentage data is that 4.5 flower. If you want to take taking like that, so this method we used here. And then here is the here I visualize only one petal length data. But if you want to visualize more, one or more, we can use it. Here is I have. If you want to pass 3, here is the 3 method I have used. 3 data I passed here. I get the result. I stored here these variables, and then we want 3 ECDF. So if you want 3 ECDF, here is the 3 flat method is 1 by 1. 3 flat I have used, and then here is the margin. This is the outline. This is the ligand means that this is a name we want here. So Sedosa, Versicolor, Virginica. So location is here. I have mentioned location. This is here. That is why ligand I used. And then is the already I showed that name of the x-axis, y-axis name. Before we go to next, this is the only visualize methods. So we all used only visualize method. So before we go to summarizing methods, mean, median, mode. So if you all run codes, like if you have any doubt, you can come. I think that all are have Anaconda Jupyter notebook, right? Just run all codes. If you have any doubt, you can ask within 5 minutes. I will move to next section. In future section, I will explain about NumPy 5. I means I will detail. I will take pandas, NumPy, C4, Matplotlib. So I will go to details. Here only I explain the outline. So only basics. Shall we move to next section? This is the quantitative exploratory data analysis. So far we see that only there is no analyze the mean median like that. We just see that how data is plotted in 2-dimensional, 3-dimensional like that. Only we see that at 2-dimensional. So now we move to analyze the data using summarize method, means mathematical methods. So here is the mean median. Here we need to talk about data, but how to talk about data? We have 10 columns. One column contains number of rows, 150, 200 like this. So we need to take a decision how to talk about with others, how to say that. If you want to say about the data to others, like mean, average. Mean means here is the average. So if you want to say about this data to others, we need to find mean values. Mean values means that this is the central position of the data. So 150 data is 1 to 150. So we need to find the central positions. So center position. If you want to find the central positions, we need to mean method. We need to use it. Here means mathematically sum of number of values by number of values, like that method. Here we use only Python contains mean method. So here we passed mean column. Here column names I passed here separately. I separated one column here. That variable is passed here to find mean values. So I want to find vertical color petal length only. Just if you pause, we'll get the mean values 4.26. This is the central position of this petal length. All understand or not? This is the median value. This is also median. Medium is the central position, but is there any outliers in data? We cannot use mean values. Mean value is not good. So okay. This is the line. Here is the one data. Here is 2. Here is 3. Like this. Here one data. Here one data. Here is the data. But mean value is here. But one data here. Okay. This if one data is too long from other data, here's all data here, but one data here, so we can call this outliers. If you find the mean values, is there 4 data like that, 1 2 3, so we want to find mean values 1 plus 3 by 3, so 3 plus 6 2. So mean values here. So like this process. Median is same thing like this. If you want to find the median values, here we can use median method, and then so here's I used here the NP. NP means here mathematical all functions here n-dimensional. If you want to mathematical operation, so you can use the numpy in Python. So np.median. This is only I print values, so output here already. So next we move to next one. This percentile. We already know that mean values, median values, central position. This median is the number values. We can find, okay, this is using that number. Okay, this is the we assume that is the central positions. So if we want to visualize we want separate the data. Separate means quartile, 20% data, 50% data, and 75. So like that, we need to separate the data. So here we have used here the percentile methods. Here we have used the 2.5 percentage data, 25, 50, 75, 95. Here I have passed the values. So in list. So here I was data is separated. Using this list values, we separate this list of pattern length column values. We get the result is the center position. The 2.5 position is the 3.3. So 25% data is here 4. So like this, we can, this is the number, but if you want to visualize, we have so another one. So all these values we can visualize easily. But we plot that two values. Here just we got plot x-axis, y-axis values. This is a ECDF method. But and then ECDF method we combine with percentiles. Why you need to pass the percentage values? Just got this 25% data. This until now, until here is the 50%, 70%, so 97%. We need to easily see that. So we used here this method. Is the next we move to another one. So here we first manually. Here is the percentage and then find and then we first. But if we don't need it like this method, we can move using this method. This is the Fox-Fisher plot. Using Fox-Fisher plot, what decision we need to take using this? This is the 25%. This is the starting. This is the range of low range. This is the high range. This is the 25%. This is the mean median values. This is the 75%. We can easily take decisions using this data, using this plot. How we can easily hear that this value is low means that all data within the near to mean values. If this is the interrange values, so 75% minus 25%, if you take this, the value is high. Interrange values is the data is high variance. Data contains a high variance. If the values, if you this gap is means that low values means that low variance. Here is the low variance, all data here. So using this, we can take decision using this is the flower petal length is all flower length is only 2. So iris vesica color length is started, flower length is started from about 3 to 5. So we can take decisions which flower petal length is high using this plot method.
How do you plot all three?
Sorry?
How to plot all three? Can you show?
Yes. Here is the
How to plot all three?
this is the mathematical method. This is the calculation.
Show the code.
This code.
Source code.
Source code.
Scroll up.
Sorry, what?
Scroll up. Yeah, scroll up.
Okay.
That's better. Get species. Okay. Species. Box plot is box plot.
Understand? Though all this plot method is to take decisions. So I already explained about the mean, median. Now we move to variance. Variance. What we need to understand the using variance. Variance means that how data is spread out in space using that. Here is the data. Here is the data. The central position is like this. Average, if you find the average values like this. But data we need to find, we need to talk about this data to others. How about this we using mean method and median. So yes, a variance is how where is the this central position to other positions like this. We need to talk about this how long data is moved from away from this mean values. This data how long away from this data. So commonly we need to talk about. So that is why we need to find variance. So that is why we need to find a variance method. We are using variance method to how data is varies together. So here is that np dot variance. np dot here is first. So values the 0.21 means less variance. If you get a large values means 1 point, 2 point, 3 points. So like that we can decide that. So we high variance. This is the low variance. So 0.21. Mean variance, and then now standard deviation. Standard deviation like that variance. Standard deviation also like that variance. But when we see that normal distribution like that, we see difference is standard deviations. So I will show you about standard deviation like this. But when I move to other plot, I will explain about detail about standard deviations. Now, until now we visualize only one kind of data. So it means one columns. So now I need to visualize two columns data. So I am using scatter plot. This scatter plot. Scatter plot in x-axis values contains petal length. This is the petal width. So two columns values I plot here, and then this information so that these are linear functions, and then data is highly varied. And this is just only visualizing purpose. Only we can use scatter plot. So plot methods. Here I passed. Until now I passed only there one column values. Here I passed two column values. Vertical color, petal length, and vertical color, petal width. And then here I was mark a dot. Line style is none. Margins is 0.02. This is the outline. X label, Y label. Here now we move to next one. Okay, scatter plot. The covariance. Covariance means that variance is using only one data. One data using the one attribute. We find how data is varied. We can take decision using only variance. So covariance tell us that two attribute how varies together. So we use covariance method. Here is this is the mathematical methods of covariance, but in future class I will explain about how to find covariance in using mathematics. This one we find only covariance methods. If you don't need mathematics, you can if you know the NumPy very well, you can find you can implement all mathematical operations. Here is the covariance. Here I call this covariance COV. I pass two attribute. Here the vesicular petal length, so petal width. I only display here 0 is a two-dimensional array. Here is a two-dimensional arrays. We get the result in two-dimensional arrays. So we distinguish 0, comma means 0 rows, first columns. These values. This goes here is the result. This full table result is here. So I want this value only. That is why here I pass 0, 1. 0 row, 0, 1. So 0 row, first column. So as I mentioned, that is why I got this result. This is a covariance. And then like that covariance, another method is correlations. So covariance, correlation. Until now this is a scatter plot tell us that a relation two attributes contains a relationship or not. Here is the if data is go like this way data is go, this we can say that is a linear relationship. Data is go like this way is the negative relationship. Yes, one data its values increases, another attribute values go negatives. We can say that negative correlations, a negative relationship like that. So that if we don't, there is no relationship, data is spread out like this. Data don't go like this or this way. This is only spread out in this central method. So, but how much relations are there? We cannot take decision using this scatter plot. So we need to take our decisions. How much how much percentage data is correlated. So that is why here we use correlations. So covariance and then correlations. Here is the relationship. This two petal length, petal width. The relationship here the 0.073 percentage. Here is the correlation coefficient is like that covariance. This is also mathematical methods. This is also mathematical. I will okay. So if you want to find the mean values, we are using mean x bar equal to 1 by n sigma xi equal to I equal to start 1 1 to n values. If you want find mean values, but you don't need using this form, this mathematical, because all is inbuilt in NumPy. So this is only understand purpose. So this is a variance. Variance value is calculated like this way, and then covariance. Right now, we saw that the covariance formula. So 2 variables. So 1 variable, 2 variables. We find the covariance here. You want to find the covariance here like this, and then so correlation is like that. It's a correlation formula. Pearson correlation coefficient. Statistics contains another methods like this correlation coefficient. We can use anything, but when you take decisions, how much percentage of correlation between two variables, so you need to use these methods. If you go to apply um, before you go to apply algorithms to machine learnings or deep learnings, you need to find all this uh, relationship. Because if you want to if you take regressions, so is there any relationship between the linear relationship, whether it is only linear relationship, so you go to regression methods. So if you want to take algorithms, you need to find all these statistical methods to take decisions. Here I used the Pearson correlation method. This is also like the covariance. Here I passed vertical color, pedal length, vertical color, pedal width. Using the 0.17 means that there is a large correlation between two attributes. If the value is low, means that the relationship between two variables is low. Okay, now we move on. So now we move to another one, is the distributions, probability distributions. So before we go to take 5 minutes and think about is there any doubt until now, please ask me and then I'll clarify, and then we'll move to next one after 5 minutes. Or
Five to one. 521 381 381 317. Same workshop will be in Raspberry Pi next week. Next Sunday it will be on Raspberry Pi. We'll show using Sunday on Raspberry. So the component is there. So next week it will be in that way. So it will be in a scattered. One thing will be here, other thing will be there, other thing. You need to do it using Raspberry. So next week of system is mandatory. At least you have at least one system that if you are not building systems, it will be shared with some other team.
ஷோ கொடுக்காம பண்ணணும். அது எப்போ பண்ணுது எந்த வருஷம் யூஸ் பண்ண இப்போ சொல்ல முடியாது. எந்த வருஷம் இப்போ சொல்ல முடியாது. அதான் நீங்க எந்த வருஷம் அதோட 2 or 3
Python 3
அதோட 3
show function.
அதோட 3 தான் நான் வச்சிருக்கேன். என்னது மேட்ச் செக் அல்ல மாடல் தான் காட்டுது. ஏன்னா அந்த மாடல் என்ன இருக்கு லார்ஜ் ஷாப்ல தான் அத பாப்போம்.
transaction discovery.
ரெண்டு கஸ்டமர் ரெண்டு மூணு கஸ்டமர் வந்து ப்ராடக்ட் வாங்கிட்டு இருக்காங்க. ஸோ
ஃப்ளிப்கார்ட்டு நான் இந்த டிவி வாங்குறேன், ஃப்ரிட்ஜ் வாங்குறேன்.
ஓகே,
நான் வந்து அடுத்தது என்ன வாங்க போகிறேன், எந்த வாங்க போகிறேன், இந்த மாதிரி என்னெல்லாம் வாங்க போகிறேன், என்ன ப்ரிடிக் பண்ணணும்னா என்ன பண்ணணும்.
இது வந்து அன்சூப்பர்வைஸ்டு. So computer want to flip the coins. That is why here function random number generator. Human can flip the coins, so we can toss or like this. We can see that. But computer want to flip the coins, so like this process, computer must do that. So that is why here we use random number generator, and then random dot seed 42 means that if we pass this value again, and then we get the same result. So same data, we want same result. If you apply many times, so we pass this seed, we pass the value 42 like this. Any number you can pass. So random number you can pass the any random numbers in seed method. But why we need to pass the values to seed method means that if we want same result, same data, if we run again and again, if we run again and again, so we need same result. That is why here we use seed method. Here I created a empty list. So the empty list values 1 lakh. 1 lakh means all is 1 lakh data is created, means all is empty. That is why you see empty values. I think so you all know for loop. So random number is generated here. This is a random method. I said that already. Flip the coins is so 0.5%. They get 0.5% tail. So Here is our random values passed here. Here is another one passed 0 or 1. So random is 1 lakh times is this action happened. So every time it happened, value is stored this here, this list. After that, that result is stored, and then we get that result. Using that result, we plot the histogram like this. This histogram sizes all are equal. That is why we call this uniform distribution. So means that this okay here there is only. So now we move to next. Next is Bernoulli. Here we need to understand only uh, what distribution here is using this method. If we like this distribution here is the uniform distribution. So I already said that about the pins values 0 to 0.1 values to here is all value contains 1 pins. Again like this ranges between these values, all values contains these pins. So here we move to Bernoulli trials. Bernoulli trials only tell that true or false. If you flip your coin, so true or false only said that. One here is the also mathematical methods, but we need only we can use only numpy. This only tell us that true and false. Bernoulli trials. Bernoulli trials also here is a definition defined means that to understand purpose only you don't need write all this code because numpy contains single line codes, so you can use it. In future sessions I will take sessions about numpy separately, numpy pandas, so matplotlib, so all this separately I will take go deep so you can understand very deeply about all codes. Here is the what is here I explain only what is happening here. That is why just you can see that just run the codes and you want to understand the single line codes, you just research in using Google. So here Bernoulli trials. Here I pass run the Bernoulli methods. Here pass true and false, and here register 0. So success or not like this, but we want to store all these values here. That is why here the random number is generated here. So after generating here the value is stored here, and then we get the result. Here there is no print function, that is why we don't get, but we want here is the values written only success values. Success values means that 1 0 is failure, 1 is success. So the 0 1 0 0 0 1 like this value is stored in this random underscore numbers, and then we use the 42, we get that result here. You got it like this, but so Bernoulli trials is the under data we pass 0.0 data is the Bernoulli. Here is a past 2 data. Here the 100 is the n. So is here is. So from here we call this method, and then we get result from here. this result is for here. And then we move to here. So all result is we need to visualize. So here is I use the histograms. So why I need to visualize the values means that I need to find if these values in uniform distribution or binomial distribution or Poisson distribution, like that. What kind of distribution these values go? So I need to find that. So here I used visualizing. So now here is the data is passed here. Here the norm equal true. True means this all values is 1, like this process. So here is a norm equal to 1. So usually all values must be divided. So if we give a norm equal to true, so we can usually true divide. So edge color is black and the line width is equal 1.2. So label name is X label, number of tables. So here is the label name. Here is the y-axis label name. This is only for Bernoulli trials. I think this same data. Bernoulli trials only we pass the true and false. Here is the binomial distribution. Now we move to binomial distribution. Binomial distribution tells us the how much success in particular values. If you this value is passed 1,000 times, like this 1,000, 10,000. Your process is repeated number of times. If you process is repeated, so we need to take decisions. Predict at 10 how much time we can get 10 values, like that 15 or 13. So we need to predict like this. So we use binomial distributions. Here is the values. After get this binomial these values, so that it's a ECDF like this process is. So values display here is that. So here here we used perform underscore Bernoulli underscore trials method. If you want to find the Bernoulli methods, here this method you need to use is a binomial. Here is the np dot random binomial. Here is the size is repeated 10,000 times. So data is 100 means the 10,000 times when you repeat only you get 100 values repeated. Means that this is a random instant means 1 to 100 values repeated. So the result is was to ECDF. That is why we get it. How is it? We need to visualize all data. That is why here is. So we can take decision is means the 80% data is above 6 values repeated. Here is the repeated is a 50% process above 4 values is repeated. So 5 values repeated. We can take decision like this. That is why we visualize ECDF. So here this is nothing. This is like that, but but here is the pin values changed. Here is the every column, sorry, every bar is the pin. So if you want define the pin values, you can pass the pin values here. You can create the pin values list, or you can pass here. You can like the pins. The process first here. Here is the first, and then I want separate every edge color. I passed edge color black line with 1.2. The same this result is showed is using histogram. This result, so random process binomial distribution values showed here is the ECDF. Here showed is histogram. It is one. But if you take this is like binomial means that mode mean values not equal, but normal distribution value is mode median mean values equal. So this the curve is like this going is means right side or left side value is skewed. If you find that this histogram means that go to binomial distribution or Poisson distribution. So here just only visualize for random numbers. We generate the just random numbers and we get the result to understand the what is to see what is binomial distribution, what is Poisson distribution, what is binomial distribution. That is for first. But if you have any real time data, when we visualize, if you see like this, so you need to take decision. Oh, this is binomial distribution. This is Poisson distribution. So when we move in future class, I will explain with the real time data. I won't show the like this. Here I use random number. Random number is only for just explanation. I give examples. So here we move to binomial. We move to Poisson distributions. Poisson distribution will happen interval times. Means that a bus is coming between interval between 1 hour 1 time. So we need to find a bus coming in features. So 1 hour 1 time is the we need to take decision like this. If you want find a Poisson distribution. So I said that this is a Poisson distribution. Binomial distribution already said that. Here the Poisson means that interval times action will happen between interval times. Yes, action is happen. Size is 10,000, and then here is the past 10 times. Means break. Here after get the results the mean and standard deviation values pass here, means just printing the mean values, median values. Here is the mean median values, and then is the nearby, and this until this is the Poisson process. Here is the binomial distribution. So here is just a comparison. but you need when you take decision this is that true and false like that in binomial, but Poisson is will happen interval. Okay, now we go to I will show that graphical. We will see that graphical is no we don't miss that. If you want display discrete values, continuous values. If you want display discrete random variables, you use the binomial or Poisson distributions. If you want to display the continuous variable, you need to use the normal distributions. So normal distributions use the density. So density graph you use binomial distribution. If you want to display by discrete variables, uh, histograms. So like we take decisions of binomial and Poissons, but in videos I will show you that. Here I don't have code to show that normal distribution. Okay. Discrete variables. All discrete variables only discrete variables, continuous variables are variables. But if you can count the variables, we can call that discrete variables. If you measure that variables like height of students in class, height of students in class, like this process is continuous variables. If you can't count the values, so you can take the variables in discrete variable. So random. So random variables means that you get the you get that outcome is randomly in the discrete or continuous. So like this, here is the purpose. The probability distribution is if you see like this like this histogram, you can assume that this is the normal distribution. So like this bell curve. The bell curve is the normal distribution. But if you want to display if you want to display discrete variables, you use histogram. If you want to display continuous variable, you use density. Yes, there is like this. If you want to display continuous variables using density curve, if you want to display discrete is a histogram. So now we will move. I explained all the details. You just run the code And if you have any doubt, you can ask. Yeah, I finished all topics. But run your code, and if what details you want to get from picture you can't understand, you can ask me and then I will explain. All understand all topics. Clear. Yeah. Just run your code. I think I have given data to all.
Hope no, this is the very basic session on data science which we have covered. Probably no, we'll get that is on tomorrow. There will be a basics on Python on at 2 to 5, right?
Yes.
2 to 5, no, same time, no, there will be a basics on Python. So you can, if you want, no, if you have registered the thing, no, you can attend the basics on Python. Then for next Saturday or Sunday, no, we'll be scheduling Raspberry, which is there. So let me just open in the site. We get a hands-on look. So you can find our 1 week before, no, we'll be posting our meetups here. Please get registered in our site. In this, you'll find a meetup. In this, no, you will find a meetup tab here. So in this, no, we would have mentioned data science, and tomorrow it's a Python, and third thing it's again on 20. On 16th and 17th June, it's a Python. It's a 2 days workshop. For that, it will be only 10 seats, not more than that. So it will be inside a room. So it will be not more than 10 seats. And for that, no, it's registration for all. No, you need to only register here. So you can just add to cart and you can register. If you are attending this free meetups also, no, please ensure that no, you register the meetups here in the site. And this would be took by Surya, the trainer named Surya. He will come on 16th and 17th of June. And you can find your recordings in meetup videos. In this, no, you can find all our recordings here. So the session which we have took today, you'll have the recording at this place. That is maybe the first place. You will have the recordings here, or you can just click on home page. Even in mobile, you can just click on that and you can see that. Maybe in 1 or 2 days, we tomorrow or day after tomorrow we'll be posting recordings here. You can just scroll down and you can see the recordings here. In mobiles, it will be very small. It will be very hard to identify. If you are clicking it, it will expand, and you can easily see that in this place. So you can see that. So to register for the meetups, you can click on this and you can register it. And to get videos, you can just click on videos and you can see the recorded sessions over there. And it will be posted in YouTube and it will be linked here, so you can easily see these sessions here, and you can click and you can practice in your home, like each and every step. You can easily able to practice. And next session we have not updated here. The next session, that is the Python session, which is on will be on the 3rd June. And on 3rd June, 10th June, no, we'll have a Raspberry meetup which is going to happen. That I'll update it on Monday exactly. I'll be updating you on Monday. So you need to again come here and you need to register it. A few people have come from that meetup site. A few people have come from meetup site, but as of now it's okay. But you need to please register here, so that only you'll be having the exact count of people. The meetups will always happen afternoon. Paid sessions will be happening morning, and meetups will be happening afternoon. And if there is any doubt, no, just get back to us. So we'll be all in the group. So if you want to add yourself in the group, no, we'll give the forms to you. You can fill up, and I will be adding you in the group which we have. So you can, if you are already the if you are already there in the part of an group, no, bigdatahands-on.com or any other group related to bigdatahands-on.com, you can, it's fine. And if you are not in that group, no, please ensure that if you want, no, you can get added to that group. So all our information will be sent. So you can see that box and you can register it. So thank you. Thank you for the session. As it's a very basic session, no, on data science. It's closed in just 1.5 hours to 1 hour 45 minutes. From next session, just we'll go in depth. If you see last sessions, IoT, Adreno, no, who took Saran and is took by Aram Kumar. So those session has gone for 5 hours until night 7 o'clock it has come. So it started at 2:30 and it has gone until 7 o'clock. Certain sessions, because it's like we have to 2-3 sessions, so it's fine. So again, next session it's on Raspberry Pi, which is going to happen on 10th June. It will be only for 2.5 hours or something like that, because it's a basic session on Raspberry. So once 1 or 2 sessions gone inside Raspberry or data science, then we will have 3-4 hours. The session will be more. Okay, thank you for the session. Thank you all. Visit you next time. Thank you. No, tomorrow. If you want, no, you can register it and you can attend. Okay. Okay.